Today we're going to continue talking about angles and properties that we have with angles. So we spoke about the angle addition postulate last class, but today we're going to talk about angle bisectors. So given the diagram, notice how x is part of the ray BX. So we can say that if ray BX bisects this bigger angle, angle ABC, then something being bisected, remember it's split up into two congruent parts, then we could say these two angles are congruent. Angle ABX is congruent to angle CBX. So the definition of an angle bisector means that a ray bisects an angle and splits the angle up into two congruent parts. So a ray can be a bisector, an angle bisector. A line can be an angle bisector, or a segment can. So we could have also said segment BX bisects, or line BX bisects, but I'm going to use the rays, considering it looks like a ray in the diagram. Okay, so we're going to mark the diagram with congruence, and we're going to, for number one, we see that ray BF bisects angle DBE. So DBE is right here, I'm outlining it. And if ray BF, so that means these two angles are congruent. Okay. If BX bisects segment AC, that means this is a segment bisector. So AB and BC are congruent. So notice how we had an angle bisector for number one and a segment bisector for number two. And then for the last one, we see that ray BD bisects ABF. So I'm going to do two tick marks on those two angles to show that ABD and DBF, those angles are congruent to each other. Okay, so let's work on an example. We know that the measure of ABX is 5x, and the measure of angle XBC is 3x plus 10. And we want to find the measure of angle ABC. So here, BX, I think this got cut off, bisects angle ABC. Okay, so if that is the bisector, we have to mark the diagram, the angles congruent. So we know that 5x equals 3x plus 10, and we solve for x. So I have x equals 5. And if we want to find the measure of ABC, I know that this angle up here is 25 degrees, and this angle has to also be 25 if it's bisected. So the measure of angle ABC is 50 degrees, an acute angle. Okay, so in this diagram, I want us to name a straight angle. Okay, so think about what a straight angle would be and how we would name it. So straight angle, I see here is angle ABC. See this straight angle right there. Okay. So the way we name that angle, we still have to name using these three vertex points, or these 3 points where the vertex is in the middle. And now if I want to give an example of the angle addition postulate, I'm going to say, how about this? There's many that you could do here, but I'm going to say angle 1 plus angle 2 equals angle ABE. So the measurement of angle 1 plus the measurement of angle 2 equals the measurement of angle ABE. So I want you all to find another example of an angle addition postulate and write that down using this language. Now the notation here with these M's, the measures of, need to be included when you're using the angle addition postulate. So just keep that in mind. All right, so there are certain things that we can assume from this picture. The first thing, we can assume that A, B, and C are collinear. So notice how we had the straight angle. A, B, and C are collinear. And then we can also say that angle ABC is a straight angle. And then we could say that we have adjacent angles, but we can't say that the angles are congruent. So if we're looking at the diagram, we may say that, oh, angle 1 looks like it could be congruent to angle 2. But when we're looking at diagrams, we can't trust our eyes. But what we can say are that angle 1 and angle 2 are adjacent angles, right? Angle 2 and angle 3 are adjacent. But one thing that we can't do, we cannot trust our eyes when looking at diagrams. Make sure you write that down. Okay, but with that in mind, we can assume a few things like these numbers 1, 2, and 3, right? We can assume that angle ABC is a straight angle because AB and C are collinear. So make sure you pause, write down what you can assume, and now we're going to talk about what we cannot assume. Okay, certain things that we cannot assume from this picture. We cannot assume that AB and BC are congruent, okay? So we cannot assume that B is a midpoint. Okay, we cannot assume that B is a midpoint. So we know that AB cannot be congruent to BC. We cannot assume that BD is an angle bisector. So there's no way of us knowing if angle 1 and 2 are congruent. We would need to know more information. We also cannot assume that angle 3 is a right angle, okay? We cannot assume that angle 3 is a right angle. It may look like a right angle here, okay? So it may look like a right angle here, but we cannot trust our eyes, so that we cannot assume. So again, we cannot trust our eyes. We must be told that angle 3 is a right angle, and then if we knew that, then we could mark it on the diagram and make other observations from there.